In order to make our pipe more interesting, we can add a start and end cap to it. Add a plane. Rotate it 90 degrees and apply the rotation by pressing Ctrl A and choosing rotation. The reason for doing this is just because it makes the modifiers a bit easier to work with later. Add an array modifier and increase the count. We can add some detail to the plane by insetting it with I and then moving the inset face along the y-axis. Add another array modifier or duplicate the existing one. Change the offset factor to the z-axis. Add a simple deform modifier and set it to bend. Change the angle to 360 degrees to make it a full cylinder. Now you can increase the count on the second array modifier to increase the diameter of the cylinder. And the first array modifier controls the length of the cylinder. For now, let's move this piece to the side. Duplicate it and move it away from the original. Since changing the geometry of the original plane changes all the instances, it's easy to make a new design. Dissolve the inset vertices with Ctrl X. From the Face menu, choose Poke Faces. Then select the vertex in the middle and move it along the y-axis to create this pyramid shape. This is called a knurling pattern, and you can find more examples of it online if you want some inspiration for more complex designs. Now let's move these two objects to the side. Duplicate one of them and move it to the right. Dissolve the middle vertex to remove the pyramid shape. Select all, right-click and subdivide. Insert it. Then from the Loop Tools menu, choose Circle. Extrude this circular selection to create a hole and then scale it down to create a slight taper. I will make the cylinder smaller by halving the count on the second array modifier. And I will reduce the first array count to 1, although I could have also just removed it. We can double the object in size by pressing S and then 2 on the numpad and pressing Enter. Now our cylinder is as big as before, but the holes are bigger. Apply the scale to avoid any issues with modifiers later. If I add a subdiv modifier now, you can see that there is an issue. This is because the vertices of the plane instances are not connected. If we add a weld modifier and move it up to before the subdiv modifier, we can solve this problem. Now I would like to make sure it doesn't look so soft and smooth. Let's turn off these modifiers for a moment and focus on the actual geometry. Press slash to isolate the selected object and reduce the visual clutter. In edit mode, go to Select Sharp Edges. Adjust the sharpness angle to get only the edge loops that you want to be sharp. Then set their mean crease value to 1. This protects those edges from the subdiv modifier, keeping them sharp while the rest is smooth. To continue working on these objects, we need to apply all the modifiers. You can do that quickly by right-clicking and choosing Apply Visual Geometry to Mesh. But as you can see in edit mode, the vertices are not connected. So let's undo this until we get the modifiers back. And then add a weld modifier. Now if we apply Visual Geometry to Mesh again, the vertices have been welded together. Do the same for the second object. The cylinder with holes already had a weld modifier. However, if we apply Visual Geometry to Mesh now, you can see that we have way too much geometry. So undo that and remove the subdiv modifier. Then apply Visual Geometry to Mesh. As you can see, the instances are connected and they have retained their creased edges. We can always add a subdiv modifier to check if there are any issues that we need to resolve. Right-click and choose Shade Smooth or Shade Auto Smooth. It all looks okay, so we can remove the subdiv modifier for now. If we want to attach these objects together, it's a good idea to make them line up better. Select both and go to Edit mode so you can see the vertices of both objects. Select the cylinder with holes by hovering the mouse cursor over it and pressing L. Then rotate it along the x-axis. From the top orthographic view, it's easier to see the vertices line up. Duplicate the cylinder with holes in object mode. Select two objects that you want to join while holding Shift, and then press Ctrl J to join them. Depending on the order of selection, you may have to set shading to smooth again. The shading is inherited from the last object selected, the active object in other words. So now we have joined these four objects into two separate objects. In Edit mode, hold Shift and Alt, then click on the boundary edge loops of these parts. Choose Bridge from the Loop Tools menu. This adds geometry in between those parts. You can inset it with I and scale it down along the normals with Alt-S. Repeat the steps to bridge geometry in the other object as well. Instead of insetting and scaling down, we can also inset and then extrude outwards. The best way to extrude in this case is to press Alt-E for the extrude options and choose Extrude along normals. Then scale down the extruded faces along the x-axis to create a tapered look. Hold Alt and click on the boundary loop to select it. I will reduce visual clutter by turning off the floor in overlays. To close this boundary, we can press Ctrl F and choose Grid Fill. Press I to inset. If we inset too far, we get these overlapping regions, which we will have an issue with later. Instead, it's better to just inset a little bit and then scale the selection down with S. Move the selection along the x-axis to create a tapered look. Inset and scale it. Then extrude inwards with E. You can delete those faces as we won't be able to see them anyway. Repeat these steps for the other object. Select and extrude the boundary loop on the other side of this object. Insetting and extruding geometry is a fun and quick way to create hard surface parts. And the good thing about it is that you can keep it all as quad geometry. I'll just quickly add a nice shiny metal matte cap to the 3D viewport, so that we can get an idea of these parts as metal objects. If we add a subdiv modifier to this part, it makes it all smooth, which is not what we want for a hard surface part. That's because, apart from the holes, no edges have been protected with creasing yet. In Edit mode, go to Select, select Sharp Edges. Crease them with Shift E and 1 on the numpad, or with the mean crease value in the option panel. In this case, we can select the edges we want without also including the edges that we don't want. So let's undo that for now and find a solution. Since we already have the creasing we want on these holes, we can just protect it by hiding them. In X-ray mode, from the orthographic side view, it's easy to select them all. Press Ctrl and minus on the numpad to shrink the selection if necessary. Then press H to hide the selection. Now we can select sharp edges and crease them. Unhide the hidden holes and everything is as we want. Repeat these steps with the other object. It looks like there's some ugly pinching going on here. We can shade it smooth, but it still looks bad. In Edit mode, if we select the vertex in the troublesome area and move it, we can see that there are in fact overlapping vertices. This can happen when you extrude something but didn't move it, So in this case, I accidentally extruded one time too many. It's easy to solve, just select all by pressing A, then press M for the merge menu and choose to merge by distance. As you can see, 40 vertices were removed, and the object looks much better. Now our two objects look nice. But if we add a cube, which is by default 2 by 2 meters, we realize that they are in fact enormous. So scale them down quite a bit and apply their scale. Move them aside and add a new cylinder. It doesn't need many vertices, 12 is enough, and don't fill the caps. Scale it down, rotate it on the y-axis by 90 degrees to align it with the other objects, and then apply the rotation and scale. Add an edge loop with Ctrl R and bevel it with Ctrl B. Extrude along normals and scale the extruded part along the x-axis. Now we can add an array to turn it into a pipe. Add a subdiv modifier and enable smooth shading. Select some edge loops for creasing to adjust the look of the pipe. You can also adjust the look by scaling some edge loops. In the array modifier, there is a caps section where you can add a start and end cap. I recommend naming these objects start cap and end cap to avoid confusion. Then add them to the appropriate fields in the array modifier of the pipe. As you can see, it looks a bit wonky now. That's because the start cap and the end cap have their origin at the side instead of in the middle, because they were made from a single plane. Select them and go to Object, Set Origin, Origin to Geometry. As you can see, this fixes the way they look in the array. Now we just have to scale down the pipe instance to match the start and end caps. This has to be done in edit mode, otherwise the caps will be scaled as well. Now you can adjust the count of the array and the caps will stay where they're supposed to. In object mode, add a curve or a path and set it to in front. Add a curve modifier to the pipe and pick the curve object. Make sure that the pipe and the curve are in the same location. Now when you adjust the path in edit mode, the pipe with caps will be deformed along with it.